Good morning, students. On continuation of fifth semester AC Motors, in this session, we are going to learn starters and speed control of three-phase induction motor, and subtopic is speed control of induction motor with diagrams. And before that, my sincere thanks and courtesy to all authors for sharing their valuable content in the internet for the sake of students. What we have seen in the previous class. In the last class, we have discussed about double cage induction motor, construction and working. In this class, we are going to concentrate on this. One is the speed control of induction motor. Speed control of induction motor by frequency changing method. Speed control of induction motor by changing supply voltage method. Let us see one by one in details. What is the known to unknown? The speed of induction motor depends on which factors? What is the synchronous speed? So that means already we know that synchronous speed is equal to ns is equal to 120 f by p. That means the speed of the motor is depend upon the frequency and number of poles. So ns is directly proportional to speed is directly to the supply frequency, and speed also inversely proportional to the number of poles. That means here if you increase the frequency, the speed will increase. If decreases, this is also decreases. But our Indian frequency almost the 50 Hz. Okay, so plus or minus 5%. So unable to control the speed with help of the government supply. So we require the separate supply where we can possible to change frequency, and that at that case it is a possible this method. And second method is the speed is indirectly proportional to number of poles. Here the number of poles at the time of the manufactured itself they decides the winding owned based on the number of poles. In intermittently we cannot change the number of poles. If there is a possibility to change the number of poles in the stator, then it is easy to change the speed. That means the number of winding coils connected in the stator, it is possible to change number of poles. Then there is a possibility to change the speed. So these are the two factors, directly factors. Now ns depend upon which factors? So frequency and number of poles. 120 is the constant. Can we change the slip of the motor? What is the slip here? Slip is equal to ns. Slip is equal to ns minus n rotor speed divided by ns is equal to slip. Okay. So that means here can we change the slip of the motor? So yes, it is possibility. When synchronous ns is called synchronous speed, n is the rotor speed. So the rotor speed depend upon the load on the motor. If load added more, what will happen? The slip increases. Okay. So here there is a possibility to change the slip also. What is the formula for speed of the induction motor? What is the speed? As we know that, so speed is n is directly proportional. N is equal to 120 f by p. This is the one formula. At the same time, n directly is equal to 1 minus s into ns This is another formula. If you know the synchronous speed, we can easily know the what is the speed of the rotor. At the same time, already we know that slip times. Okay, so that means slip also can change with the help of the rotor losses. That means here rotor copper loss is equal to slip times of P2 rotor input. So from this also we are going to change the speed. How we are going to change? If P2 rotor input, if the rotor copper loss known, S will change. If S substituted, N will change here. Okay, so this is some known to unknown. And before that one, so we have seen how to change the motor speed in case of DC motors. In previous classes, we have seen that shunt motor. How we have changed the shunt motor? So this is the armature A and AA, and shunt motor is connected through this one, and we change the speed. So we have seen that the speed control of shunt motor with the help of the two methods. One is the field control method, field current control method. Another is the armature voltage method. Okay, armature voltage method. That means if you are changing the ear by using the rheostat, the flux will change, so automatically the speed will change. Okay, so already we have seen that what is the formula? EB is equal to 5ZN by 60 into P by A. Okay, so here I require the speed. The speed can change with the help of the flux. So speed and flux is inversely proportional, as N is into 1 by 5 here. So here you can see it. So that means by changing the flux, we can change the speed. At the same time, so the EB also plays a vital role. How we are going to change that one? So here the speed, that is whatever the EB is the back EMF. Okay, so armature control method, we know that. What is that one? So we applied voltage is equal to induced EMF plus IA RA. Okay, drop in the armature. So difference V minus VB, that means here also the back EMF changes, so speed also the change. That means in second case, the voltage applied across the armature, if you added some resistance here, what will happen? So that means you can see that is also in armature control method what we have seen. So here we connected the armature, we connected some resistance here. Okay, then we connected the directly okay, we connected the feed. Now what is happened? By changing this voltage, whatever the voltage is applied shared by this resistance and this resistance, then what will happen? By change, we can inject the voltage across the armature terminals with the help of this one. If applied the full voltage, motor will run. So because we know that the speed is directly proportional to the V, or that is called EB. Okay, if voltage is more, speed will more. Voltage is less, speed will less. That is the armature voltage control method we have seen in previous semester. Okay, so but here what is happen? Whether it is possible to change in field coil or in armature is not possible in case of our induction motor, because only plus minus here we can easily control it. But whereas in our synchronous motor, what is the induction motor? What will happen? 3-phase windings won't. And rotor is whether it is a slip ring induction motor or a squirrel cage induction motor. So here it is not possible to change this field control method or armature control method. So we require the another methods we are going to adapt to change its speed. Okay, so we can change the speed by changing the from stator side. Stator side, we can control the speed from the stator side, from rotor side also, rotor side. Okay, so these are the few methods in stator side, and at the same time the rotor side also we have the few methods. As per our suitable applications, we can control the speed of the induction motor with help of these methods. What are these methods? How we are going to control the speed, we can see in details. Okay, so these are the basic things, dear students, already we have seen in previous classes. Okay, now classification of speed control in induction motors. So what is the speed control here? There is a speed of the induction motor can be controlled with the help of the three methods. One, change in frequency. We have seen that. What is that one? So N is equal to 120 F by P. Here the speed N is directly we can change by using the frequency. Okay, the change number of poles by changing the number of poles. Change slip, that is equal to S, that is equal to N is equal to 1 minus S into Ns. So that is the S here, S. So this is the change in frequency, change in number of poles, change in slip. And the change in slip is further classified into the rotor circuit resistance control. That is this is a rotor side. By adding some resistance in the rotor side, we are going to control the speed. And stator voltage control. So just now we have seen. Next, rotor voltage injection method. That means we are injecting some voltage into the rotor from outside. We are going to control the speed also. Okay, so these are the classification of speed control in induction motors from stator side and rotor side. Speed control of an induction motor. A three-phase induction motor is practically a constant speed motor, just like the motor or the more or less like a DC shunt motor. Okay. The speed variation of a DC shunt motor is possible within wide range with a good efficiency merely by manipulating a simple field rheostat. The same is not possible with the induction motors. So what are the methods we are applied in DC motors is not applicable in three-phase induction motors. In case of induction motors, the speed variation is accompanied by a corresponding loss of efficiency. If we are trying to change those methods, here we are going to lose the more losses, at the same time frequency also, that is efficiency will decrease. Okay. In case of induction motors, the speed variation is accompanied by a corresponding loss of efficiency, where in case of DC motors loss may not be there, efficiency is nearly equal, but in this case we are going to lose some amount of the losses maybe takes place. If the losses is more, automatically efficiency of the motor will decreases. That is why it is much easier to build a good variable speed DC shunt motor than a variable speed induction motors. So you have to choose where we require the constant speed and where we require to frequently vary the speed. At that condition, we are going to adapt to the DC shunt motor. Okay, but it is a costly. DC supply is required, the separate arrangement is required. But whereas our induction motor is a rugged motor and easily controlled, but we have also some methods to control the speed. But comparing to the DC shunt motor, somewhat here is the losses are more. The speed of induction motor is given by, so as in that N is equal to Ns into 1 minus S. N is the rotor speed, ns is the synchronous speed, s is the slip speed. Where synchronous speed ns is equal to 120 f by p. At the same time, we know the equation also 120 f by p, and the slip s, that is equal to rotor copper losses by rotor input. So as we know that, so here what we have seen, rotor copper loss, previous class we seen rotor copper loss is equal to what are the P2 into slip times, we are going to get it. So here S is equal, what will happen? So if it will come here, that is the formula, same thing here. Okay. Hence, from the above expression, it is clear, it can be concluded that speed of motor can be changed either by changing its synchronous speed or by changing its slip. So either way we can change the speed. Okay. So that means here what is this one? So here the speed n can change with help of the speed of the motor can be changed either by changing the synchronous speed, or by changing the slip. Okay, it is slip. Therefore, the speed of induction motor can be controlled from stator side. As we know that this is the stator. A stator are in the winding, 3-phase winding, R phase, Y phase, B phase winding, and this is the stator, and it is the rotor. So rotor is the squirrel cage induction motor or slip ring induction motor. So we are going to control the R phase, Y phase, and by changing the voltage, changing the frequency, and changing the number of poles, we can change the speed. At the same time, rotor side also we are going to change. Now let us see, so from stator side, how we are going to, what are the different methods to change the speed of our induction motor. Okay. Now what are that one? By changing the number of, so by the supply voltage, by changing the supply frequency, by changing the number of stator poles. These are the stator side. And coming to the from the rotor side, by changing the rotor circuit resistance and by injecting the voltage into the rotor. Dear students, just you see here. So it is possible in case of slip ring induction motor only. So here stator has the 3-phase winding and rotor has rotor winding. Okay, if you have seen that one rotor winding have the slip rings, and from slip rings we are taken the outside. Here we are going to add some resistance in the external circuit, the single phase, the 3-phase connector, star connector. By changing the rotor circuit resistance, so already rotor winding have the some resistance. So in addition to this one, we are going to add some extra resistance outside, so we can change the speed of the motor. That is the thing. Next, by injecting the voltage into the rotor side, instead of resistance, so by injecting connecting the some voltage source outside, that is going to inject inside. What will happen? Already rotor winding induces some voltage ER, rotor voltage. By injecting the some voltage from external voltage, so difference will change. That means the current flowing through the rotor circuit is changed. During this process, we are going to change the speed. That is the second concept. And another is a cascading control. That means here is one motor and here is another motor. Both rotors are connected and supply is given to the ear. It will run based on the number of pole designed. Next, this is disconnected, then connected to the same supply, and it runs based on its own P2 speed. So we are going to get this speed and this speed. And sometimes we can connect to the cascading P1 plus P2 number of poles, that is another speed, and P1 minus P2, this is another speed. That means in cascading method we are going to control the 4 methods: only P1, only P2, only P1 plus P2, and P1 minus P2. So we are going to control this method is known as the cascading method, side by side method. Okay. Let us see these methods also in details. First of all, frequency changing method. We know that the synchronous speed ns is equal to 120 f by p, and n or rotor speed is equal to 1 minus s into synchronous speed. So this can be written as 1 minus s into what is the ns, substituting in this equation. Substitute this equation here. So we are going to get this one. Okay, then by gradually changing the supply frequency, ns synchronous speed and the motor speed can be increased or decreased smoothly. That means supply frequency changes, its speed also changed. You can see here. So nr is equal to 120 f by p into 1 minus s by keeping the one constant at a time. Now, electronic scheme for the VIF control. So, here what is the one problem is taking place. In what is happened? Now, what is happened here? This is a stator, and stator has a winding. Okay, then there is a rotor, and here is a rotor wing. Here you can see, so there is a air gap here, stator and rotor air gap. Here air gap, whenever the three-phase supply is given to the stator, it produces the constant magnetic field. Okay, so that is it is rotating E phi r at rotating 1.5 times of phi m, maximum flux produced by each phase, and this produced flux is rotating in the air gap at a speed of ns is equal to 120 f by p. Okay, now so this rotating magnetic field rotating at this speed and producing the air gap in the flux constantly. If change the frequency or if you change the voltage independently, then what will happen? The flux in the air gap may be leading to the saturate. If saturation takes place, automatically the motor performance value changes. So we don't want that disadvantages. So here, so we are going to maintain the ratio of V by F. That means voltage by frequency, we are going to maintain some constant value. So then we are going to maintain the constant flux in the air gap. Otherwise, there is a saturation of the air core, that is a core material takes place. It leads to so many disadvantages. Hence, we are going to voltage. If we are going to increase the voltage, automatically frequency has to decrease. If frequency you are going to increase, voltage has to decrease. Such a way that V by F the value, what are the value we are going to get, that should be the constant of that motor. Such a way that we are going to control. How it is possible? So in electrically it is not possible, but we are going to use in the electronic circuit where we are going to maintain the V by F ratio. That is just like we are going to see the V and inverted V cos experiment. We are going to do the same thing. Now let us see the V by controls. How we are going to control this one? You can see, dear students, here. Okay, so what is here you are going to see? We require the variable V by F we are going to control. That means here variable voltage is required. Here variable frequency is required. But so it may be possible voltage by using the auto transformer or something. But frequency cannot change. In auto transformer, whatever the primary frequency is equal, secondary frequency cannot be changed. That may be constant 50 Hz in India. Now, how we are going to change? If the voltage changes, frequency has to change. How we are going to change? But it is a constant given by the NPTEL people. So that purpose, we have to change ourselves the frequency from the 50 Hz to another frequency with the help of the electronic circuits. Okay, here you can see the circuit how this is connected. Here AC supply is given from the DISCOM people. Okay, so DISCOM people, they are given the constant voltage nearly plus or minus 10%, constant frequency plus or minus 5% they will give. Okay, so here what is a single phase? For example, single phase voltage 230 volts, or in case of 230 volts single phase voltage, or 400 volts in three phase circuit. Okay, so plus or minus 10% voltage, and this frequency f is equal 50 Hz they will give, and plus or minus 5% they will give. These are the ranges they will give. This is the value. Okay, now this whatever the AC is converted using the rectifier, by using the electronic rectifier diodes. So we are going to convert the AC to DC by using the rectifier or converter. After that, the DC, whatever the DC will come, this is a constant direct current. So here by using the inverter, what it can convert the DC to AC, DC to AC. Here whatever the AC I can control with the help of the these electronic circuits. I can change the voltage, I can change the frequency. So independent of the DISCOM people frequency, this one. So by using the electronic circuits inverter, I can change the variable voltage, variable frequency. So that can be used in my case V by F method. I can variable voltage is available, variable frequency is available. We can change this one, maintaining the constant here. Okay, then if by changing V by F maintaining, so we are going to control the speed of the motor. This is the concept, dear students. So what we are going to see here, normal AC supply is coming from the DISCOM people. So that is changed into the variable voltage and variable frequency with the help of our electronic circuits. How we are going to do in? So AC is converted into the DC with the help of our rectifier units, and from this DC we can control as per our requirement variable voltage and variable frequency with the help of inverter circuit. Then there is a provision for variable voltage and variable frequency, so we can control the speed of the induction motor. Okay, so this is a basic concept. Now the provision for supply of variable frequency can be made by consumers by having a separate arrangement such as solid state equipment, that is SCRs, diodes, IGBTs, MOSFETs. So whatever the latest solid state devices can be used to control these things. Okay, or rotary converters. This method so far had limited applications because the cost involved in arranging the variable frequency of power supply is very costly. With the recent development in semiconductor devices, the frequency control method of speed variation of induction motor is becoming very popular. A change of supply frequency changes the synchronous speed and provides a direct method of speed control. To keep the air gap flux constant, what is the need to change the two variables? Here is to keep the air gap flux constant, that is 1.5 times of flux produced by each phase. So phi r is equal, what is the value? So that is equal. So each phase, R phase, Y phase, B phase, this phase is producing the flux, maximum flux, and so this is also producing, this is also the same. Then resultant phi r is equal 1.5 times of phi maximum flux produced by each phase. This is the resultant flux. So this flux should be maintained constant in the air gap. Okay, to keep the air gap flux constant, the supply voltage must be changed so that the ratio of voltage to frequency remains constant. Okay. Otherwise, the magnetic circuit may become saturated, resulting in excessive magnetizing current drawn from the supply. Unnecessarily, the over bill to our tariff, our payment, we are going to do it. Okay. So, that means what will happen if magnet is saturated, to develop the same torque and same work, so we have to draw the more current from the supply. That is a undesirable things. Therefore, the method is also called V by F control of the motor. Hence, in this method, the supply to the induction motor is a variable voltage and variable frequency supply, and can be achieved by the electronic scheme using the converter and inverter circuit, as we have seen in the figure. Okay. By selecting the proper frequency and maintaining the V by F ratio is a constant, the smooth speed control of the motor is possible. Okay. So, another is the method is the speed control of induction motor by changing supply voltage method. Okay. First case, we have seen the how we are going to change the V by F method, frequency control method. Okay. So, directly instead of changing the only frequency, we are also consider the voltage also. Otherwise, so there is a drawbacks maybe takes place. That is why we are going to V by F control, ratio of V by F control we use to change the speed. And second case, the speed control of the induction motor by changing the supply itself, input itself. Okay. So, here that is a V by F, that the frequency can change, voltage changes. Let us see. The torque developed by the induction motor is proportional to the square of the voltage. As we in previous classes we have seen that the torque, whatever the torque developed in the motor is directly proportional to the square of the voltage and slip times. If the supply voltage is reduced below rated value, torque also reduces because T is directly proportional to the square of the voltage. To produce the same torque for the supplying the same load, the slip has to increase. So, what is happened here? So, we know that torque is directly proportional to the slip into V squared. Okay. So, now what is happened if you are going to decrease the voltage, input voltage, but to meet the same load. So, what is happened? The motor is running now. Okay. So, running, it is connected to the mechanical to some applications. It is going to the giving the some application some. Now, what is happen if your normal voltage is applied, V is equal to applied, normal voltage applied, the motor is running at normal speed and it is meeting the our applications. Now, in second case, I want to change the speed. Then I am going to reduce the voltage with help of the variac. Voltage is reduced. Then what will happen? But if voltage is reduced, our motor try to meet the same load application. So, what will happen? So, automatically it try to maintain the same torque to meet the same load. Hence, here voltage is decreased, forcefully here decreased. It has to maintain the constant speed to maintain the constant load. So, this is a constant, this is the reduced. Then what to do? To maintain the constant T, so S should be increased. Slip increases means what is the slip? S is equal to Ns minus Nr. Okay, rotor speed. That here slip has to increase. Increased means here Ns minus Nr gap should be increased. Okay, gap should be increased. How you are going to? Ns is a constant. Ns is equal, what is that one? Ns is equal 120 F by P. We cannot change this one. It is running at, suppose 4-pole machine, it is running 1500 RPM. Okay, 15 RPM. So before going to reduce the voltage, our motor is running, for example, 1440 rpm. Okay, now 1440 rpm, synchronous speed is the 1500 rpm. Okay, slip is the 1500 minus 1440 divided by 1500. We are going to get some slip. Now, due to the, if you are going to decrease the voltage, supply voltage here, then it has to meet the same load. The torque produced in the motor is tried to maintain the constant. That purpose, the slip has to increase. The voltage decreases, slip increases. The slip increased means what is happened? So difference between the ns minus nr has to increase. That means the rotor speed has to decreased. Instead of 1440, it is reduced to the 1300 rpm. So if 1300 rpm speed reduces, the slip also ns 1400 minus this 1300, the gap increases, slip increased. Okay, a slip increase such a way that, so if this decreased, slip has to increase. If slip increases, speed decreases. Okay, rotor speed decreased. Then we are going to get the 1300 rpm instead of 1440 rpm. That means our aim is reduce the speed. That here, what we are going to do, by changing the voltage, the speed of the motor changed such a way that, okay. These students, don't confuse here. These all are the just basic equations. Okay, let us conclude it. To produce the same torque of the supply, the same load, the slip increases, the motor running at low load speed to decrease the supply load. So load is same. To meet the same load, it requires the same constant torque. Torque is constant. Voltage is decreased, slip has to increase. If slip to be increased, speed should be decreases. That is the concept. The speed, the maximum torque developed is reduced. Automatically, the maximum torque developed at the induction motor at the condition of rotor resistance equal to the rotor reactance. Rotor resistance constant, but rotor reactance changes based on its frequency value or based on the slip value. Okay, automatically slip now increased. The reactance value changes. So what is the constant basic things? T max. Okay, max and torque is equal to, so where what is already wherever the at the condition is equal to R2 is equal to S into X2. So whenever the rotor resistance constant equal to the this value, so this is a variable value. So what will happen? The slip value increases now in this case. So this value changes. So this value changes whenever the product of S and X2 equal to R2, then maximum torque produced changes here. Okay, so that means the previous case the torque is here. In this case the torque. So previous case we are going to get the speed n is equal to 0, n is equal to ns. So we are going to get the nearly here n is, we are going to the higher speed, we are going to the maximum speed. Now due to the reduced speed we are going to get the early the maximum speed. That is the concept. We will see the diagram also. Okay, the maximum torque developed is reduced considerably with the slight reduction in speed. The torque speed characteristics at reduced supply voltage shown in the figure. You can here see it. Previous case, dear students. Here what will happen? Normal, under normal condition without any reduction of supply voltage. So the whatever the maximum torque is produced at this speed. Okay, so this is the starting torque, this is the maximum torque. Now in second case, once the voltage is supply voltage is reduced, then slip has to increase. Slip increases, speed decreases. Okay, now automatically speed will decrease. You can see this is the speed is decreased. N is equal to 0, n is equal to this synchronous speed. This is ns. Now instead of getting the maximum speed at this higher speed, it is going to reduce the only here maximum. Okay, but that means this is the difference. At this condition we are going to get the maximum torque. At the same time magnitude also changes. This magnitude is a maximum here also. At the same time at speed at which it occurred also changed. Okay, this is the second case, this is the first case. First case we are going to get that this is the maximum torque and this is the at which it is occurred the speed. In this case we are going to get the maximum torque is reduced compared to the previous case. At the same time the speed of the rotor also reduced. Okay, so that means speed from this speed to this speed we have reduced the motor speed. Okay, torque speed curves. This method is simple and cheapest method, but it is rarely used because a large change in voltage is required for small change in speed. Here what is the one disadvantage? In this method, simple and cheapest method, but it is rarely used because why? The large change, here T is directly proportional to the S into V square. So V square means voltage has to change the maximum value, large amount of the value to change the speed very less. So because V square, large amount of the voltage you have to change the speed, small variation of the speed only. That is the disadvantages. This method is used on small motors driving fans whose torque is proportional to the square of the speed. Okay, so these are the basic idea regarding to the speed control of induction motor. Okay, so let us summarize what we have seen in this class. We have discussed the method of speed control of induction motor, speed control of induction motor by frequency changing method, speed control of induction motor by changing supply voltage method, and from this one we concluded that the speed can be controlled, changed in induction motor by supply voltage and supply frequency. So dear students, this is a small topic. Thank you for listening my class.